Good morning, students. Today we are going to study the next lesson of the 8th unit, what is called nucleus. Everybody knows about nucleus. Atomic nucleus is the central core of an atom, which contains all the atoms' positive charge and almost the mass, the mass of the atom is also concentrated at this place. This is called nucleus of the atom, right? So nucleus is the central core of an atom, which contains atoms of all positive charges, and the entire mass of the nucleus is concentrated at this place, at the center of the atom. Atomic number of an atom is the total number of protons present inside the nucleus. It is denoted by Z, right? Then mass number is the total number of nucleons. Total number of nucleons means protons and neutrons together present inside the nucleus is called mass number. Mass number is noted by the letter A. Number of protons is equal to Z. Mass number of protons is equal to atomic number. Mass number is given by is given by A. A means the total number of protons and neutrons present inside the nucleus. And therefore, number of neutrons is equal to total number of nucleons minus the number of protons. That is equal to A minus Z. Right? So, number of neutrons equal to A minus Z. Nucleus notation. Nucleus notation is I am writing here. It is known as X A Z. X A Z. So this is the way how a nucleus is denoted, where X is the symbol of the chemical element, and A is the mass number, and Z is the number of protons present inside the nucleus. Then is nuclear mass. The total mass of the nucleons present inside the nucleus is called nuclear mass. Atomic mass are measured, most of the time, atomic masses are measured not by using the conventional unit of mass like kg, grams, etc. But it is measured in terms of a special unit called atomic mass unit. An atomic mass unit is the mass of 1/12th of the mass of a carbon atom. Carbon is C12(6). The usual common carbon atom is C12(6). 1/12th of the mass of a carbon atom. Which carbon atom? C12(6). Right? Or the mass of C12(6) into 1/12 is equal to 1 AMU. Right? So 1 AMU is equal to see, it is given. 1 AMU is equal to 1.66 into 10 raised to minus 27 kg. This can be proved, right? Nuclear mass is measured in AMU. 1 AMU is equal to 1/12th of the mass of C12(6) atom. Right? 1 AMU is equal to 1.66 into 10 raised to minus 27 kg. Right? To convert AMU into kg, multiply that amount of AMU with 1.66 into 10 raised to minus 27. Any mass in AMU, when multiplied with 1.66 into 10 raised to minus 27, we can convert AMU into kg. Right? AMU into kg. Example, mass of an electron. ME, when we write, you understand that this is mass of an electron. Mass of an electron in terms of AMU is marked here is equal to 0.0055 EMU. That is converted into kg. To convert the AMU into kg, we will multiply it with the value of 1 AMU. That amount of AMU into mass of that means AMU in kg. That is 1.66 into 10 raised to minus 27. So we get the mass of an electron is equal to 9.11 into 10 raised to minus 31 kg. You can take the mass of a proton in terms of AMU, multiply with the value of 1 AMU in kg. 1 AMU in kg is equal to 1.66 into 10 raised to minus 27. Then you can get the mass of proton also in terms of kg. And the same is the case with neutron. If you know the value of neutron in AMU, multiply that with the 1.66 into 10 raised to 27, you will get the mass of a neutron also in kg. It is also usual in atomic physics to express masses in terms of energy. So most of the time, masses are not termed in terms of mass only, but it is usually in atomic physics, it is usual to express all the masses in terms of energy. So we will calculate now the energy equivalent of 1 AMU. Because everybody knows that Einstein's relation, this is called mass energy equivalence is equal to mc square. According to that, mass is also another form of energy. If m is the mass of an object or anything, and c is the velocity of light, then energy equivalent of that value of mass mc is given by E is equal to mc square. In this case, if m is equal to 1 AMU, then the energy equivalent to 1 AMU is equal to 1 AMU into c square. But 1 AMU is equal to 1.66 into 10 raised to minus 27. That is 1 AMU into c square. C square is 3 into 10 raised to 8 meter per meter. This is meter per second. Then this is multiple. You will get 1.66 into 10 raised to 27 into what? 3 into 10 raised to 8 the whole square. This is in joules actually. In the SI system, we are getting the value of energy in joules. That joules, when converted to electron volt, we will divide that with the value of 1 electron volt. Every student knows that the value of 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. The total value of energy in joules divided by the value of 1 electron volt in joules, you will get the number of electron volt you will get. So this one 1 AMU, 1 atomic mass unit is equivalent to 931.5 into 10 raised to 6 electron volt. 10 raised to 6 electron is equal to mega. Therefore, this can be written as equal to 931.5 mega electron volt. What's the meaning of this? That means 1 AMU equivalent to 931.5 mega electron volt. This is a very, very important information you are getting. Right? Okay. That means any amount of atomic mass to convert into energy, you have to multiply that with 931.5. Then you will get the energy of that mass into that much mega electron volt. So any mass in AMU to convert into energy equivalent, you have to multiply it with the value 931.5, right? Then the energy equivalent of that mass you will get in terms of mega electron volt. So this is a very important information. So to convert any mass in AMU into mega electron volt, multiply with the quantity 931.5. So very, very important information. Then is size of the nucleus. Nucleus is considered as the atom itself is considered as spherical in shape, right? By Rutherford and also Niels Bohr all said atom is spherical in shape. This nucleus is also considered as spherical in shape, right? Nucleus is considered as spherical in shape, hence the size is measured in terms of volume, and volume in turn is directly proportional to number of nucleons present inside the nucleus. Volume of a nucleus is directly proportional to number of nucleons. Number of nucleons is equal to mass number. As mass number increases, number of nucleons also increases. So hence we can write 4 by 3 pi r cube. Volume of the nucleus 4 by 3 pi r cube is directly proportional to A. What is R? R is the radius of the nucleus, right? So 4 by 3 pi is a constant. Therefore, we can write R cube is directly proportional to A, or R is directly proportional to A raised to 1 by 3. We can write, right? So this proportionality is converted into equality, then we have to multiply this quantity with a constant. Therefore, R is equal to R0 into A raised to 1 by 3, right? Where R0 is a constant whose value is equal to 1.2 into 10 raised to minus 15 meter. As mass number is different for different atoms, hence the size of the nucleus is also different for different elements. So different elements, the nucleus is of different size. For example, the nucleus of oxygen is not same as the nucleus of uranium. So uranium is a heavy atom whose atomic number is greater than 230. Atomic mass number is greater than 230, while oxygen it is very less. Therefore, the size of the nucleus of oxygen or hydrogen is not same as the size of the nucleus of uranium or any other atom. Right? Then what is density? Density of the nucleus is given by density is equal to mass divided by volume. Mass is equal to mass means MA. M means the mass of each nucleon into the total number of nucleons present. That means total mass of the nucleus is equal to mass of each nucleon into total number of nucleons. That is M into A divided by 4 by 3 pi r cube. Mass per unit volume. This is equal to MA divided by 4 by 3 pi into, everybody knows that R is equal to R0 into A raised to 1 by 3. Therefore, 4 by 3 into pi into R0 A raised to 1 by 3 the whole cube. So this bracket when removed, that means MA divided by 4 by 3 pi into, this power is distributed. You will get R0 cube into A raised to 1 by 3 the whole raised to 3. That is equal to A. A and A cancel. We will getting 3m divided by 4 by 3 by R0 cube. The value of R0 you know, and also m you know. The mass of each nucleon, proton and neutron are of the same mass, right? That is equal to 1.66 into 10 raised to minus 27. Proton mass is also approximately equal to 1.66 into 10 raised to minus 27. Therefore, 3 into mass of any nucleon. That means nucleon is the particles present inside of the nucleus is protons and neutrons. Protons and neutrons are of the same mass. The proton mass is equal to 1.66 into 10 raised to minus 27. That is the mass of one element, right? One element is m. How many? So 3 into m divided by 4 pi into R0 cube. R0 cube is at 1.2 into 10 raised to minus 15 cube. This value are getting as equal to 2.3 into 10 raised to 7 kg per 17 kg per meter cube. Every nucleus has the same density. So it is a very, very heavy density. So density of nucleus, the density of nucleus of any atom is the same value, that is 2.3 into 10 raised to minus 17. So it is very clearly seen that the mass, that means the density, the density of the nucleus of atom is very, very high. Very, very high, because the nucleons are very closely packed inside and the density is very, very high, is of the order of 10 raised to minus 17 kg per meter cube. Next is mass energy relation is also a topic that is clearly mentioned in the syllabus. Mass energy. So according to Einstein, mass is another form of energy, right? That means energy, that is mass and energy are interconvertible. Energy can be converted into mass and mass can be converted into energy. If m is the mass and E is the energy, so according to Albert Einstein, we can say energy is equal to mc square, where c is the velocity of light. According to Einstein, the change in energy is followed by a change in the mass of the system. In a system, if there is change in the energy, there will be a corresponding change in the mass also. So that is the change in mass is equal to change in energy divided by c square. Therefore, change in mass is equal to delta E by is given by what? Delta E divided by c square. So this is another important point I wanted to teach you in this class, right? So this also. Then next topic we have to talk is mass defect. what is mass defect? That I am going to explain you. Mass defect. When a nucleus is constituted by bringing nucleons from different locations, I mean infinite locations, and the nucleus is constituted, then it is seen that the total mass of the nucleons when separately calculated, and the and the mass of the nucleus is measured after making it as an assembly, then there is a slight change in the mass. For example, so many nucleons are bringing from infinite locations and we are constituting a nucleus, right? You first of all do one thing. You take the mass of all the nucleons required for the assembling the nucleus separately. All the masses, all the separate. Suppose 10 or 15 nucleons are there to be used for making a nucleus. All these 15 entities, the mass is separately calculated and keep aside. Now we constitute it and make the nucleus. Then after becoming the nucleus, after making the nucleus assembly, again the mass is taken. You will see that the separately calculated mass of all the nucleons is always greater than the mass of the assembled nucleus. There is a slight decrease in the mass. And this decrease in the mass is called mass defect. This mass defect is equal to the sum of the separate mass of the nucleons minus the mass of a nucleus. So we can write delta M. Mass defect is denoted by delta M. Mass defect is given by delta M is equal to the mass of the protons plus, that means ZMP plus A minus Z into Mn. Mn, this is the total number of the total mass of protons and neutrons separately calculated. This is always greater than the mass of the assembled nucleus. If this from this the mass of the nucleus is subtracted, that is mass NuC. Mass of the nucleus is subtracted. There is a small value you will get. That is what is called delta M. This is always, that means the mass of the entities used for making the nucleus is always greater than the mass of the assembled nucleus. This difference is called mass defect. It is denoted by delta M. Right? So here MP is mass of the proton and Mn is mass of the neutron and MnUC is the mass of the nucleus and all. Right? Then what is called binding? This difference in mass is actually converted into energy. This energy is called binding energy. So inside the nucleus, you know that protons and the neutrons are there. There will be attractive force. So there is there's an energy is required to bind all the nucleons, because protons are always repelling according to electrostatic force. We know that proton is positive charge will repel each other. To keep these protons and protons inside the nucleus, a kind of energy is required to bind them together. And this energy is actually derived from the mass defect. So the difference in the mass of the separate mass, the total mass of the entities used for making the nucleus, that will be always greater than the mass of the nucleus. This difference in the mass is converted into what is called binding energy to hold the nucleons together inside the nucleus. Right? This binding energy is given by binding energy will represent as equal to EB. EB is equal to delta M into C square, where delta M is the mass defect. So everybody knows what is mass defect. Mass defect into the square of the velocity of light is what is called a binding energy, denoted by delta EB. Right? So, but actually, binding energy is defined in a special way. Binding energy is defined as the energy required to separate the entities inside the nucleus to infinite separation. If there are so many nucleons present inside the nucleus, the total amount of energy required to liberate every nucleon to infinite locations. This is what is called binding energy, is the way how it is defined. No doubt, there is nothing to surprise. The right amount of energy is required to constitute the nucleus. So the amount of energy required to constitute the nucleus is same as the amount of energy required to liberate the nucleons to infinite separation. It is denoted by EB. EB is equal to delta M. Delta M, everybody knows. Delta M is equal to ZMP. That is equal to ZMP plus A minus Z into Mn. Mn, right? Minus MNUC. MNUC, the whole into C square, right? This is delta M. This much is delta M into C square. The total amount of total mass of the separate mass of the nucleons minus the mass of the nuclear assembly, that is equal to delta M into C square. This is what you call binding energy. So binding energy can also be given by EB is equal to, binding energy can also be written as EB is equal to, that I am going to write, is also given by EB is equal to ZMH plus A minus Z into Mn, right? Minus into Mn minus Mx A Z the whole into C square. This way also this can be expressed, right? Because but we know that we have already done that delta M is equal to ZMP plus A minus Z into Mn minus MNUC. This only we have seen as delta M, right? Okay. Now we will add and subtract the mass of electron present in the atom. That is, this can be adding and subtracting the mass of electrons present in the atom. Then we will get ZMP plus A minus Z into Mn plus ZME. ZME means as many as protons are there, same number of electrons are there, right? Number of protons equal Z. Therefore, number of electrons is also Z. Therefore, mass of entire number of electrons is Z into Me, right? Here this are added. Then we will subtract it from this one. Again, MNUC minus ZME, right? This is equal to ZMP, mass of the total number of protons. This is also taken here. ZMP plus MP plus ME. MP plus ME plus A minus Z into Mn minus of MNUC plus ZME. MNUC plus ZME, right? MP plus Me means mass of a proton plus mass of an electron. Hydrogen atom contains one electron and one proton, right? Therefore, mass of a proton and mass of electron is same as equal to MH. This is equal to ZMH. So you may doubt why MP plus Me is written as equal to MH, because mass of a proton, hydrogen atom contains one proton and one electron, right? So mass of a proton plus mass of an electron is same as equal to mass of hydrogen atom plus A minus Z into Mn. This is MNUC, mass of the nucleus plus mass of total number of electrons. That is the total mass of the atom itself. Total mass of the electron, mass of the atom is given by minus X A Z, MX A Z. This is mass of the atom itself. So therefore, delta M can be written as equal to ZMH plus A minus Mn minus M XAZ. XAZ is the mass of an atom, right? Therefore, EB is equal to delta M into C square. That is same as equal to ZMH plus A minus Z into Mn minus MXAZ the whole into C square. So this is what is called the binding energy. So today onwards you will see that binding energy is nothing but it is the energy required to bind the electrons together. It is specially defined as the energy required to separate the nucleons from the nucleus to infinite locations. Remember, the right amount of energy is required to constitute the nucleus, and to make an assembly of the nucleus also same amount of energy is required. Next is what you call, so binding energy is also done. So binding energy is a very important topic. So this way it can be derived. You can take down this notes from this board, right? Okay, thank you. Next, what I'm going to talk is about nuclear forces. Nuclear forces are very strong forces. These nuclear forces are acting between the nucleons inside the nucleus. Nucleons are mainly protons and neutrons. So protons and protons repel each other, and neutrons does not make any attractive or repulsive force. But inside the nucleus, as proton and proton are there, there will be a repelling force, right? But the making of the nucleus, it is done in a very quite different way. In this case, the nuclear force, that means nuclear force is only attractive force, right? This is not electrostatic force. There is no electrostatic force acting inside the nucleus. Electrostatic force is between the nucleus and the electrons outside. But inside the nucleus, there will be only attractive force. Proton, 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 neutron, neutron, proton, etc. There will be an attractive force will be there between. This is a very, very strong force between acting between them. So they are these forces are strong attractive forces. They are charge independent and also short range forces. So short range forces means at a distance of about 0.75 into 10 raised to minus 15 distance when they are existing between two nucleons. The force of attraction is very, very maximum. This graph is also improved what I am going to draw here, right? So this graph is important. This is repulsive force. Repulsive force. Force is increasing. This is attractive force. Attractive force, right? And this is 0.5. This is 1.0. This is 1.50. This is 1.50.